diazotization reaction. So what is diazotization? Di means two, azo means nitrogen atoms. Okay, when two nitrogen atoms are joined together, like N2, okay, that is called as diazo. So diazotization reaction that can also shown by the primary, secondary and tertiary amines with different products that we will see. So what is the statement of this reaction? Amines on reaction with nitrous acid. So this nitrous acid, what is this nitrous acid? That we will see at 0 degree Celsius or below 0 degree Celsius. So this is the speciality of this reaction, that the reaction takes place below room temperature or at 0 degree Celsius, you can say. Okay, both the reaction contains, that is your amine and the nitrous acid, that is the mixture of this nitrous acid, they are freezed, they are below 0 degree Celsius or at 0 degree Celsius temperature. Then and then that diazo compound is stable. Okay, so we'll see the reaction. So there is different reaction for aliphatic and aromatic amines. Okay, so this diazotization, whatever the diazotization takes place on aromatic compounds, there are many reactions or many functional groups you can form with this aromatic diazo compound. So we will see this one by one. So what is this nitrous acid? How this nitrous acid is formed? Okay, so in different reactions or different books, the nitrous acid is given, then sodium nitrite is given. So how this nitrous acid is formed, that we will see first. So we'll see the reaction and the examples and explanation of this diazotization reaction now. Now here, diazotization reaction. Diazotization reaction. What we need here? We need nitrous acid. Nitrous acid. What is the structure of nitrous acid, or what is the formula of nitrous acid? It is nothing but the HNO2. Nitric acid is HNO3. Nitric acid, HNO3. One oxygen is coming. Okay, here this one oxygen atom is less. Nitrous acid is HNO2. How this nitrous acid is formed? It is formed by combination of NaNO2 plus HCl. NaNO2 plus HCl form this HNO2 plus NaCl. This is your nitrous acid. Okay, so this is your sodium nitride and this is hydrochloric acid. They form here this nitrous acid. In some of the reaction condition, arrow condition is given as HNO2 directly, and at suppose cold condition. Okay, or in some of the reactions it is given as NaNO2 plus HCl at cold condition. Both these are the same reactions. Do not confuse with this, because the mixture of this NaNO2 and HCl, that is going to form this HNO2. Okay, now we will see, this is the reagent that we are using for diazotization reaction. Now what is the reaction with primary amine, secondary amine and tertiary amine, that we will see now. So diazotization with primary amine. So primary amines means here RNH2. So this is primary amine which is aliphatic in nature. Okay, so this is aliphatic primary amine. This on reaction with HNO2 at cold condition. This is also cold at cold condition. Amine is also taken at cold condition. Please remember this. All the reagents and the reactants we are using in this reaction, they are taken at the or reacted at the cold condition, means 0 degrees Celsius or below 0 degrees Celsius. Then and then the reaction product can be formed. Now this HNO2 means here this is nothing but the NaNO2 and HCl. Okay, this forms R N triple bond N. This is plus and Cl minus. This hydrochloric acid, this is the Cl. This is nothing but the alkyl diazonium chloride. Alkyl diazonium chloride. Understand? But this alkyl diazonium chloride is not stable because this is alkyl group. I'm going to explain this for aromatic also. This is not stable, and this further reaction or further on hydrolysis produces ROH plus N2. Okay, and this chlorine goes with the one of the hydrogen atom, that is plus HCl, alcohol. So the primary amines first gives you alkyl diazonium chloride, that is the salt, which on further hydrolysis produces this alcohol. Nitrogen is obtained as a byproduct, and this is HCl. Okay, if you want to prepare, so if I consider the example, if I want to prepare ethyl alcohol, so what you have to do, you have to take ethyl amine CH3 CH2 NH2. Okay, now this ethyl amine on first reaction with HNO2 at cold condition gives product A, which on further reaction with H2O gives your ethyl alcohol CH3 CH2 OH. Byproducts, you know the byproducts now. They are the N2 and HCl. Understand this reaction now? Okay, so this is with the primary amine. So what is the reaction with the secondary amine that we will see now? Secondary amines, diazotization. So secondary amines on diazotization gives nitrosoamine, that is called as nitrosoamine. Nitrogen containing oxygen, that's why it is nitroso. Okay, how? See here, this secondary amine RNH, here also R. This on reaction with HNO2 at cold condition. Again NaNO2 plus HCl. You can write any one, or for your understanding I am writing both these reactants. This at cold condition forms this R N R, then here N double bond O plus H2O. This is nothing but the dialkyl nitrosoamine. Understand? And this dialkyl nitrosoamines whichever formed in this reaction, they are insoluble in water. This is with the secondary amine. If I take the example, suppose here CH3 NH CH3. So what is the reaction with HNO2 at cold condition? The product is nothing but the, if I write this product in different fashion, CH3 two times, because this CH3 group are two times, N double bond O, dimethyl nitrosoamine plus water molecule. It is dimethyl nitrosoamine. Understand this? And what is the reaction with tertiary amine? We have seen primary and secondary amines which are aliphatic in nature, R groups. Okay. Now we'll see the reaction with tertiary amines. Diazotization with tertiary amines. If you see the tertiary amines, there is absence of hydrogen atom. Okay. Therefore, again, as like the tertiary alkyl ammonium halide that we have formed as a product or as a salt in one of the reaction, that is alkylation reaction, similarly such type of product is going to form, that is a salt. Okay, we'll see the what is going to the product. So tertiary alkyl amines, so these are the tertiary alkyl amines. Okay, so tertiary amines which on reaction with nitrous acid HNO2 at cold condition gives R N R R. I am writing this R downside. Then here this is attached to NO2. Here it is plus, means here it is HNO2. Okay, so this is called as trialkyl ammonium nitrite. This is the product. Understand? What happens with aromatic compounds now? Okay, primary aromatic amines. Primary aromatic amines. Next page I am going to take this primary amines which are aromatic now. Okay, aromatic. So aromatic means you have to consider this aniline, benzene ring with NH2 group. This is aniline, or it is aminobenzene, which on reaction with HNO2 at cold condition, this is the mixture, that is NaNO2 plus HCl. Okay, this aniline is also taken in, suppose your test tube, and that is also cold. Nitrous acid mixture, that is also cold, and if you add this nitrous acid in this aniline, what happens? There is a formation of diazonium salt. So this diazonium salt is like this, N triple bond N, this nitrogen is plus, Cl minus. Okay, this is benzene diazonium chloride. So this benzene diazonium chloride is used as a starting compound for many of the aromatic compounds, for the preparation of many aromatic compounds. You can prepare halobenzenes, then you can prepare cyanobenzene, you can prepare phenol, you can prepare simple benzene with the use of this benzene diazonium chloride. This is very important starting material which is formed in this reaction. So one of the exceptional reaction is there, that is with the tertiary amines, which are aromatic amines, that we will see now. Secondary, again that secondary amines are going to form the uh, nitrosoamine, okay, and the tertiary amines, now see here secondary amines that we have already seen. Secondary amine, they are going to form n alkyl, okay, nitrosoamines. But what is the reaction with tertiary amine, that we will see now. If this is clear to you, then we will proceed for the next tertiary tertiary amines. So what is the reaction with tertiary amines, which are aromatic in nature? So aromatic tertiary amine, here if you see, this is the benzene ring. At least one benzene ring is required for tertiary aromatic amines, CH3 twice. Okay, so this nitrogen is tertiary nitrogen. Why? Because two R groups are there, two alkyl groups are there, and one benzene ring is there. Understand? Now this on reaction with nitrous acid HNO2 at cold condition. Rather than giving the salt which we have seen for the aliphatic amines, this aromatic amine gives benzene substituted. Okay, so it gives para substituted nitroso product. So what is the product here? This is the product. So this N double bond O. So this is the benzene ring. There is no any reaction with this tertiary amine group. Okay. So why para product is there? Para nitroso. This is para nitroso. N dimethyl N comma N dimethyl aniline. Okay, but if you see the tertiary amine which are aliphatic, they produces the salt, but tertiary amines which are aromatic in nature, it produces the para substituted product. Why para substituted product is formed here? There is an also explanation for this, because this nitrogen contains two methyl groups and these methyl groups are bulky in nature. That's why the reaction, the tendency of this particular functional group is the electron donating group. So it gives you the substitution at ortho or para position. But the product is formed at the para position because of these bulky substituents, that is two methyl groups. Understand this? So we conclude here. For such important and informative videos, please subscribe to my channel Chemistry Learners and don't forget to press bell icon button. Thank you.